Okay, so here we go with strong mathematical induction. Okay, so we start off the same, show true for 0, and then we're going to assume true for a range of values. So that's the difference. We're going to assume true for a range of values, and then we'll show the k plus 1 is true. So how do you know you're going to need this strong induction? Well, when you're be given, it has two terms, right? So this is the one we're going to prove here. Your given starts off with two terms, and look at this recursive one. It's defined in terms of the 2 before it. That's when you're going to need to know to use strong induction. Again, we always prove the nth term. This is the one we're always proving. Okay, so here we go. So we have to show true for two values, for the 0 and the 1. So plug in 0 into here, right? So I get 5 to the 0 minus 1, so that's 0, check. And then put in 1 into here, so 5 to the 1 minus 1 is 4, check. Okay, so I've shown it true for the first two. So this is the different thing. So I'm going to assume it's true. And so this is, they tell us for k is bigger than 2. So assume it's true for k bigger than 2 that this is true. So notice I have to use i's in my assume true. So assume, I guess I didn't write the word assume, but I'm supposing it's true. So I'm assuming it's true for all i's, and the i's range between 0 and k. So I'm allowed to use this all the way through. Okay. So now I'm going to show true for k plus 1. Again, you're always proving this one. So put in s of k plus 1 equal 5 to the k plus 1 minus 1. And this I'm going to show it's true. And I'm going to be using all the ranges of k's or before that as well. All right, so remember to prove it, you go to the recursive definition. So I start with the recursive definition, and then I put in the plus 1, the k plus 1. So that turns into s sub k, and that turns into s sub k minus 1. Okay, so I start with this, and then I'm going to be using hold on. So I start with this. Okay. So here it is here, right there. Okay. So I'm going to put, so I want to, where did I have this? Showing true. Oh yeah, this is what I want to show, right? I want to show this is true. I guess I just wrote it again. Okay. So I want to show that's true. Okay. So from here, I go to here. And now I'm ready to put in what I've assumed in for the s sub k and the s sub k minus 1. So what's s sub k equal to? S sub k, using this, right, is 5 to the k minus 1. S sub k minus 1, using this, right, is 5 to the k minus 1 minus 1. Okay, so then here comes just algebra. 6 times 5 to the k minus 6 minus 5 to the k, right, and multiplying these two together, and then plus 5. Okay, so let's see how many 5 to the k's I have. So here's a 5 to the k, here's a 5 to the k. So 6 minus 1, that gives me 5 to the k's. And then this minus 6 and this plus 5 gives me a minus 1. Then if I add the exponents, there it is. Ta-da! So this one you get to do on your own.